Institute of Engineering and Technology.
Start. Hello students. In this talk, we are going to discuss our last topic of this syllabus, that is application of integral. In this part, we are going to see what do we mean by integration in real life situations. Like suppose a particle is moving on a sine wave, then what is the total distance traveled by that particular particle? I'm not asking about displacement, I'm asking about total distance. What is length of that path? It is quite difficult to find this answer. One more thing, suppose you have a curve and if you rotate it through x or y, then it will give you a surface in 3D. What is the surface area of the 3D structure? And if you have a regular solid and if you want to find its volume by cross section, how to use integral? These three main parts are going to be discussed in this talk. I am pretty much sure that at the end of this, you will see some new insights of integration. Let us start with this by a simple geometric application of integration. What do you mean by value which you are receiving at last of integration? For example, if you take integration 0 to 1 of x dx, your answer will be x square by 2 with limit 0 to 1. And that simply gives you answer 1 by 2. My question is, what is meaning of this answer 1 by 2? You need to focus on this value first and then you can generalize the whole concept up to this engineering applications. So without wasting much time, let us start this thing, that is applications of integrals. My first application is volume using cross section. Suppose you have this kind of solid represented by blue color, and then if you take a section in the between of this solid with length delta x, then that area which is generated is given by ax. If you take sections of this solid in same manner from point A to point P, so you are chopping your volume into small thin layers, and then you are finding area of the thin layer, and by taking addition of all these thin layers, you are finding the answer of volume. It is the same example of finding volume of a book. You have a book, okay, and then you take one page out of it, you find area of that page and then count how many pages are there. Ultimately, it will give you volume of the book. Same technique I am using over here, but now it is for any random solid. So the formula is something like this. You take integration from A to B, ax dx. Ax is nothing but the thin layer which is our cross section. Let us consider one example. Suppose you want to find volume of solid which is lying in the first quadrant, which is bounded by y equal to x, y equal to 0, x equal to 1, so that every cross section of the solid is perpendicular to x-axis and it is semicircle. So this is the situation. X-axis, y-axis and z-axis. And then you can see the solid which is lying parallel to x-axis. It is starting from 0 and eventually it is increasing with x equal to 0, y equal to 0 to y equal to x. And then the cross section is nothing but semicircle. So if I want to apply the formula for this, I need to find what is diameter of the solid. So it is on the line y equal to x. So the radius of this solid is r equal to x by 2. And the area of this particular section which is denoted by red color in between ax is pi r square by 2, as it is a semicircle. I am taking full circle pi r square and dividing it by 2. If I take full circle, then the radius is nothing but x by 2, as the length of this d is starting from x equal to 0 ending at y equal to x. So it is x by 2. And then if I take input of this value into my formula a to b ax dx, it is pi x square by 8. So my final answer is pi by 24. So this is how very easily you can find answer of any random volume using this method of cross section. You should try to find volume of sphere also using the method of cross section, as the cross sections are going to be circles. This is exercise for you. Let us consider one more part, that is how to find length of the curve. If I have this type of curve, y equal to f of x, starting from A ending to B, and then if I want to find length L for this curve, how to find this length? So what I'll do, I will zoom in to the smallest possible part, and then I'll figure out what is actually this length in a smallest possible part. So if you reduce the length of this up to a single point, then in the neighborhood you will figure out that it is nothing but a straight line, and that straight line is nothing but tangent. This is how we are dealing with the tangent of the curve. So here, small deviation in x is dx, small deviation in y is dy, so the ratio is dy by dx, and therefore that small length dl is root of 1 plus f dash whole square dx. This value is nothing but Pythagorean value. So how to apply this formula in general? Suppose I want to take length A to B. So what I will do, I will collect all small such pink lines starting from A to up to B. That means we are considering small line segments which are in union converting our length L. So if I want to go for the example, my question is find the length of this line y equal to 7x plus 2 and from x equal to 2 to x equal to 6. What I'll do, I will take my function f of x as 7x plus 2, so f dash is 7, a is 2, b is 6, and then the formula is like this, root of 1 plus f dash whole square dx from a to b, a equal to 2, b equal to 6, f dash is 7, so ultimately it is 20 root 2. So this is the length of this line from point a equal to 2 to a equal to 6. Now let us go for the last part of this discussion, that is how to find surface area or the area of surface of revolution. If we have a curve y equal to f of x and if we rotate it through y-axis, what will happen? It will generate a solid. If I am taking this area, but now if I take only that curve y equal to f of x, it will give you a surface. How to find area of that surface? So area of that surface of revolution is given by x-axis, rotation of axis is x-axis, it is given by s from a to b 2 pi y root of 1 plus f dash x square dx. How this value is generated? If you look carefully, 2 pi r is nothing but circumference of that particular section, and then I am rotating that circumference using this technique of multiplying it by root of 1 plus f dash x whole square dx. Now at this particular moment you should pause and you should check how to derive the formula for the same question if I am taking rotation about y-axis. Okay, so it will give you 2 pi x root of 1 plus dx by dy whole square dy. Y is from a to b. So you need to take values of y, range of y, and then you can evaluate it into same manner. Let us consider one example. Suppose I want to find surface area of a solid which is obtained by revolving y equal to root of 9 minus x square in between minus 2 to 2. Then here my value of f of x is y equal to root 9 minus x square. So f dash x is minus x upon 9 minus x square raised to 1 by 2, a equal to minus 2, b equal to 2. And then what is area of surface of revolution about x-axis? The formula is something like this, 2 pi y, which is nothing but root of 9 minus x square, into root of 1 plus f dash, which is nothing but dy by dx, so it is minus x upon 9 minus x square raised to 1 by 2 whole square dx. Now simplify the square root first. So it will result into 3 upon 9 minus x square whole raised to 1 by 2. And then ultimately whenever you will simplify this, it will result into 6 pi. So my final answer is 24 pi. So I hope all of you are now pretty much clear about this idea of applications of integral, like how to apply integration in a case which is other than finding area only. Although I told you in the beginning of the lecture that what is actually meaning of integration for function of one variable. I asked you the same question for 0 to 1 x dx and your answer was 1 by 2. If you draw the graph of x, y equal to x, then in between 0 to 1 the total area covered by this region R, which is generated by x equal to 0, x equal to 1, x axis and y equal to x, is nothing but 1/2 units. So remember, whenever you are finding answer of integration, the value which you are receiving that indicates area which is covered by this function. But then the question would be, sometimes it may happen that your answer of integration is 0 and in the worst situation it is negative. What do we mean by that situation graphically? If your answer is 0, that means the area above x-axis is exactly same as area below x-axis. And if your answer is negative, that means area below x-axis is bigger than area above x-axis. So it is known as in general vector area. Now we already discussed double integration also. At that time also I mentioned that double integration will give you volume. And whenever your answer is positive, your volume above xy plane is bigger than volume below xy plane. And whenever your answer is negative, volume below xy plane is bigger than volume above xy plane. And last case, whenever answer of integration is 0, volume is equally distributed through xy plane. So that whole concept was actually generalized by this concept which I discussed in my last talk. I hope all of you enjoyed all of the sessions of Mathematics 1. If you have any doubt or any queries, you can generally contact me. Thank you.
LJ Institute of Engineering and Technology.